All right, so in the previous two videos, we learned two important things. The first thing is that when we are passing things into function, when we are passing arguments into functions, it is important to know the type of the arguments and to adhere to the type specification of the function signature of the argument list. So if a function takes an integer as an argument, we cannot pass in a string, the compiler is going to complain. So we need to know the types of the arguments that we're passing into a function. Secondly, we also learned how to identify the type of a function itself. So we need to know what the type of a function is if we want to pass in a function as an argument into another function. So we've learned these two things, and in this video we're going to apply that knowledge to actually see and understand the idea of passing functions as arguments into other functions, and then talk about what closures are and how closures relate to this idea. All right, so now you're going to see for the very first time, at least in this video, a function that takes a function as an argument. And really what this is, it's not so different from the functions that you've seen before, except that the type of the one argument that the doSomething function here takes is not a single value, so it's not the same as an integer or a string or something like this. It is actually a function. So my function, the argument, is a function itself, and it's of type int to int. So the function that we're passing into the doSomething function will be of type int to int. So that means it takes two integers and returns one integer as a return value. All right, let's again also consider the whole add function here. And please note that this is, again, only pseudocode, so it will not compile like this if you've got a function signature like for the doSomething function on top, and then you're putting the add function right below. So the first one is only to illustrate what a function signature looks like, and this add function here only recaps the add function that we saw on the previous slide. And what you'll notice about this now is that the add function, as we found out in the previous video, is of type int to int. So the types actually match up. The doSomething function takes a function from int to int, and the add function is a function from int to int. So theoretically, it should be possible to pass in the add function into the doSomething function. And in fact, that is exactly what can be done. So in a very simple case, in a very simple call to the doSomething function, it could look like this, that we're basically only passing in the name of this function that has the right type into the doSomething function. All right, so let's now actually go and talk about closures. Because what closures really are, and that's the good thing about them, that is that you don't have to learn like a completely new concept, because what really closures are functions without names. And that's also why we call them anonymous functions. So if you need to remember one thing from this lesson, it's that closures are functions without names. So how can we go transforming a function into a closure? I've got 4 simple steps for this process to happen for you guys. So whenever you want to transform a function into a closure, the first thing that you need to do is to remove the curly braces from the function. So the part where you have the function body. And I will have an example in the upcoming slides, so don't worry if you don't understand everything just yet. The second step is to add the in keyword between the argument list and the function body. The third step is to remove the function name and the func keyword. And then finally, you have to surround everything with curly braces. And what this would look like for the add function that we have up here on the slide again, applying these 4 steps, would look like this. So at first, we've got the full add function, and we're removing the curly braces as this was the first step in the process. The second step is to add the in keyword between the argument list and the function body, which we're doing here. The third step then is to remove the func keyword and the function name, which we're doing here. So we're left with only the argument list and the return type in the function signature. And finally, what's happening is we have to surround everything with curly braces and now we just created a closure from a function with a name. And as an example of how we can now use this closure, so rather than passing a function by name as we did before with the doSomething function where we were passing in the add, we can now equally pass this whole functionality as a closure. So here we have the same syntax that we are using for function passing, and it shows how to use closures to be passed into other functions as arguments. And here I've really just touched on the surface of the topic of closures. There are a lot more topics to explore around closures, and I want to name a few of them here and give a small outlook as to what other topics are related with closures. So first, closures are very often used in the context of callbacks and completion handlers. So this is a major application domain of closures in general, and if you've already worked with some kind of API, it's likely that you've used closures there, but maybe not fully understood how they worked. And in general, we have a lot of syntactic sugar for writing closures in Swift, which makes them a very appealing feature in general. And I'm going to show you a couple of these syntactic sugar elements in the next videos, where I'm going to show you an example in the playground. Then closures are also an essential concept for doing functional programming, which is a programming paradigm that increases safety and has a couple of other beneficial features when you're writing code. And finally, also note that there are a couple of memory management pitfalls. So with closures, it's easy to create retain cycles inside your applications. So in upcoming lectures, we're going to discuss this a bit more in detail as well.